Hello, so in this video, we're going to use a quadratic function to solve an application problem. So for example, in this one, the length of a rectangle is 3 more than its width. If the area is 40 square inches, what are the dimensions? Well, you will start with drawing the graph. Always start with that when it comes to a geometry problems. So now we have a rectangle and we don't know the width and the length, but we know that the area is equal to the width and times and is equal to 14 inches. 14 square inches. Now, how do we find the dimension? Well, since we don't know, for something that we don't know, we will set that equals to x. So if I set the width equals to x, and the length is 3 more than the width. So that means the length is equal to x plus 3. Now we will have our equation, which is x times x plus 3 equals to 40. Okay. Now we need to solve for x to find out what are the dimensions. So x squared plus 3x equals to 40. And then we set the equation equals to 0. Now, you can either use a AC method to factor it, or you can use quadratic function. I will start with AC method because AC method usually is the easiest one. So I have x plus 8 and then x minus 5 equals to 0. So the solution is either x plus 8 equals to 0 or x minus 5 equals to 0. So x is equal to -8 or x equals to 5. Since we're talking about dimensions, we can have a negative number, so we're going to drop the negative number. So that means the width equals to 5 inches, and then the length is 5 plus 3. So the length is going to be 8 inches. So here is another example. So if each side of the square is increasing by 6, the area is multiplied by 16. And then they want you to find the dimensions of the square. Okay, again, you're starting with a graph. And then you want each side, let's say originally the side is x. So that means the original area of this square is equal to x squared. That's the original one. And now you increased by certain dimension on both sides, so you will get a new square. So we don't know how much they increase. Let's say they increase by 6. So that means the dash line, the sign is x plus 6. So that means I have x plus 6. The area is going to be x plus 6 squared. That would be the area of the new big square. And then this is going to be the square multiplied by 16. So the original one is x squared. You multiply by 16. So that means you're going to be 16x squared. Okay. So now we can solve this. We have x squared plus 12x plus 13x equals to 16x squared. The first step is you want to set the equation equals to 0. So I will have -15x squared plus 12x plus 36 equals to 0. You can try to factor it, but this looks a very hard thing for me to factor. So what I'm going to do is I apply the quadratic formula. Our a is equal to -15, b equals to 12, c equals to 36. So by quadratic formula, I have x equals to -b plus or minus square root of b squared minus 4 times a times c over 2 times -15. And then, of course, we're going to have a negative solution. You want to drop that because the sign needs to be positive. So I'm going to leave it there and let you calculate that. So here is another example. The length of a rectangle is 4 greater than the width. In each dimension is increased by 3. The new area will be 13 square feet larger. Find the dimension of the original rectangle. Well, let's draw a graph and see what does this look like. The original one we don't know, but what we know is there's the length and the width. If the length of the rectangle, the length of the rectangle is 4 feet greater than the width. So that means if the original one, the width is equals to x, so the length is going to be x plus 4. Now they have a new rectangle. The new rectangle is going to be bigger than the original one, and because each dimension is increased by 3. So that means this is going to be x plus 3, and the length is going to be x plus 4 and plus another 3. So the original area, the old area, is equal to x times x plus 4, length times width. The new area is equal to x plus 3 times x plus 7. And what do we know? The new area will be 13 square feet larger. So that means the old area plus 13 is equals to the new area. So with these, we can set up the equation as x times x plus 4 plus 13 equals to x plus 3 times x plus 7. So here is the equation. And then how do we solve it? It looks so complicated. Well, once you set up the equation, the first thing is you want to simplify it and merge all the like terms together. So in here, I have x squared plus 4x plus 13 equals to x squared plus 10x plus 21. Okay, merge the like terms. Then I got x squared, they cross cancel. And then I have 6x, because I'm subtracting 4x on both sides. And then subtracting 21 on both sides. I will have 6x equals to 12. So x is equal to 2. Now we can find the dimensions. If x equals to 2, so that means, let's go back. What's our x? X is the originally the width dimension. So x equals to 2, so that means the originally rectangle is the width equals to 2 feet, and then the length is equal to 6 feet. Again, so to solve this geometry problem, what you want to do is you make a circle and figure out, hey, what's the relationship? And the area is the length times the width, and the relationship is the old area is 13 square feet less than the new area. So that means they will have the old area plus 13 is equal to the new area. That's our setting. And then once you figure out it, you simplify it, and then merge the like terms, you will be able to solve the variable x. Okay, let's do another examples. So the area of a rectangle is 168 square centimeters. The perimeter of the same rectangle is 52 centimeters. And what are the dimensions of the rectangle? All right, so we have a rectangle. So we got a rectangle. We don't know the width and the length, but we know the area is the width times the length equals to 168, and the perimeter is equal to 2 times the width plus the length, which is equal to 52. Now we have two formula. With these two formula, two equations, sorry. With two equations. With these two equations, we can solve two variables. So the width times the length equals to 158. From the first one, I have the width equals to 168 divided by L. And then I can substitute into the second equation. I got 2 times 168 over L plus L equals to 52. Now I can solve for L. Multiply by 2, I got 336 over L plus 2L equals to 52. Okay, so we have a fraction. How do we solve it? You can multiply the L on both sides. By doing that, we can get rid of the denominator. I will have 336L plus 2L squared equals to 52L. Then I can merge the like terms by subtracting 52L on both sides. So I will have 2L squared plus 284L equals to 0. Now I can factor it. I can factor the 2L out. Then I have 142. L plus 142 equals to 0. Oh, I make the tiny mistake. When you times the L, this L is already gone. So I just have 336 plus 2L squared equals to 52L. Okay, let me rewrite these and set this equals to 0. So I have a 2L squared minus 52L plus 336 equals to 0. Well, to solve that, the first step is you want to set divided by 2 on both sides, so I can factor the 2 out. They have a common factor 2. So this is equal to 26L plus 168 equals to 0. We can try to factor it and see if that works. We want two numbers multiply to get 168 and two numbers add equals to negative 26. So I have 14 times 12. When these two multiply together, I got 168. And since we have a negative 26, so that means we have two negative numbers multiplied together. So I have L minus 14 and L minus 12 equals to 0. So our length is either equal to 14 or our length is equal to 12. So after we find the length, either one of these, that means we have two options, and then we will be able to find our width by substituting in here into our function, because we know that the width times the length is equal to 168, and let's say if our length is equal to 14, so that our width is equal to 12. And if we do the other way, let's say if the length is equal to 12, and then you will find out, if you do the calculation, you'll find out the width is equal to 14. So either way should work because they're both positive. You can have the length 14 and the width is 12. They actually to become the same rectangles. Let's do our last word problem. An 8-inch by 12-inch picture has a frame uniform width around it. The area of the frame is equal to the area of the picture. What's the width of the frame? So when you're doing that, you would like to have a picture in here, right? That is going to be your picture. And then outside of the picture, you want to add a frame. in here, and they will tell you that, hey, the picture is 8 inches by, oh, sorry, I should say 12 inches by 8 inches. And then the frame has a uniform width around it. So that means this distance should be the same. If this is X, this should also be X. I mean, this is not a nice picture, but the idea is all of these surrounding width should be X. So what would be the width of that? And also, they give you very important things. The frame area, which is this part, the highlighted yellow shade part, is equal to the picture area. In this case, the total yellowed area should equal to 2 times the double of the picture area. Okay, so the picture area equals to what? The picture area is equal to the length times the width of the picture, which is 12 times 8. So what's the area of the yellow rectangle? So the first is we need to know the width and the length. So the length is going to be 12 plus 2x, because on the left, on the side, you add in the width surrounding the picture. So it's 2x, similarly to the width, you add in the similar width, which is x inches on the top and on the bottom. So that means you need to add 2x from 8. Okay, so the area of the yellow rectangle is 8 plus 2x times 12 plus 2x equals to 2 times 12 times 8. And then you will try to simplify the question and solve it. So in question like that, is what we care about is how do we set up the question and how do we break down each language and convert it into a mathematical language. So in this case, it would be easier for us to draw a graph, so it will help us to visualize the answer. So that's it for today's lecture. Let me know if you have any questions.